Assalamualaikum warahmatullahi wabarakatuh. Good evening to all participants. This evening we have special event for all. We call this event Electrical and Computer Engineering Distinguished Lecture Series. Please introduce my name to now. I am Head of Master Program of Electrical Engineering, Faculty of Industrial Engineering, Universitas Ahmad Dahlan from Yogyakarta, Indonesia. I would like our thank to all organizers, speakers, and also all participants. For your information, this event is organized by Master Program of Electrical Engineering, Universitas Ahmad Dahlan, and supported by Electronic System Power Electronic Research Group. This evening, we have two distinguished keynote speakers. First speaker, Professor Manish Bharat from REVA University, Bangalore, India. And second distinguished keynote speaker, Professor Dr. Vorapoj, Patanavijit. In this opportunity, I would like our gratitude to all distinguished keynote speaker, to all participants. Professor Mani Bharat from REVA University in this event will deliver his current research about Jesus inverter technology, especially for application in electrical vehicle and hybrid electrical vehicle. And second distinguished keynote speaker, Professor Dr. Vorapoj Patanavijit, he will deliver his current research in area of computer vision, especially about interactive mean filter. Today presentation will be moderated by Yulia Mega. So let us together to listen their presentation.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good evening, everyone. Langsung saja kita mulai acara kita dengan judul Electrical and Computer Engineering Distinguished Lecture Series. Kita langsung ke sesi yang pertama, yaitu dengan tema ZSI Inverter Technology yang akan disampaikan dengan Profesor Manish Bharat. Kepada Profesor Manish Bharat, kami persilakan. Mr. Professor Manish Bharat, the floor is yours.
Thank you for my introduction. So can I share my screen? So myself, Manish Bharat, Assistant Professor, School of Electrical Engineering, Electrical and Electronics Engineering, REVA University, Bangalore, India. So I'm from India, and I thank Dr. Professor Samuthprakarn sir to give me opportunity to put my research work in the international platform. Thank you, sir. So my topic. So my title of my work is jet source inverter technology, and the which in the area of electric vehicles and hybrid electric vehicles. So I'm doing my doctorate under that my research supervisor, Dr. A.S.R. Murthy sir. He's a retired professor from RRC Bangalore, and he worked in CPRI, one of the government institute. And my mentor and my guide, co-guide, as my Dr. Ritesh Das sir, he is associate professor in Department of Electrical and Electronics Engineering, REVA University, Bangalore. So in this 45 minutes of journey, I'm going to go with introduction, literature survey, problem statement, objective of my work, conventional circuit and its analysis, proposed circuit and its analysis. Then I'm going to compare those two, and finally I'm going to discuss the results and other parts of my research work. So the one of the important thing is why I went for this research topic, as we know that whole world is moving for the green energy, green and the clean energy. If you take any power energy side, you everyone is behind solar energy or wind energy or the thermal or all the geothermal energy to convert or to generate the clean energy which is going to help our future in terms of future. When I'm talking about future, means future kids after 20 years or 40 years, my son or daughter or my granddaughter, what type of world they are going to live. So all depends on us who are currently doing the research on the area of this renewable energy sources. And second part, when I'm talking about, that is nothing but the transportation sector, because we know that as the country is growing, the population is growing, and because of the population, this transportation sector is playing a major role when you are going to the office or you're coming to the office. So everyone in this stage, they are busy schedule, they are not taking any the facilities provided, the like bus services, and also they all are having one transportation, and mostly all the transportation is based on the fossil fuels. And if you see this fossil fuels, which is nothing but it is doing the carbon emission, and most of the pollution, the air pollution is happening because of this transportation sector. So last 5 years in India, we have seen a massive growth in the sector of transportation. And when we talk about this electric vehicles and all, so my work is based on the application of EV. I'm not designing an EV, but I am supporting the EV by my inverter technology. So here I am mostly I will talk about the jet source inverter and its application and how it's going to be useful for the different types of electric vehicle. So as we know that this electric vehicles is separated or divided into four parts. So one is called as battery electric vehicle. Second is known as plug-in electric vehicle. Third is nothing but hybrid electric vehicle, and fourth is nothing but the fuel cell electric vehicle. Now, what is battery electric vehicle? So, battery electric vehicle where we are using the lonely and sole it will be only the lithium ion or any other type of battery, and those battery will be replaced after some distance, after 50 kilometers or 100 kilometers. Means you have to charge the battery and you have to replace the battery. So next is plug-in hybrid electric vehicle, where we are going to use the battery inside the car and we are going to charge to the AC, and where the inverter comes into the picture. And the third one, we can see that hybrid electric vehicle, what we are not seeing in the market because of the disadvantage of switching from one step to another stage. So that is one of the challenging parts. So hybrid electric vehicle means that one source will be the fossil fuel or any the other source. A second source may be your lithium ion battery or fuel cell. When you are integrating two different sources, such as fossil fuels and battery or fuel cell, then that type of electric vehicles are known as hybrid electric vehicle. And recently, which is not till now, this is in the research, and still few of the companies are working on this fuel cell electric vehicles, which will give the longevity and we will not talk about the battery management system, because other three we require battery management system. But when you talk about fuel cell, it will give you the larger range, but the challenge is the cost. So designing a fuel cell electric vehicle is right now it's challenge in India. Other countries they are developing, but still the most used electric vehicles right now we are going through with the plug-in electric vehicle. So my work, what I have concentrated on the plugged-in electric vehicle, and if we'll go something like a battery electric vehicle. Now, electric vehicle and its components. So we can see in the left-hand side, we are having whatever things I have discussed right now, that hybrid means we have to use two sources. One source will be fuel cell, other source will be some fossil fuel in terms of petrol or diesel. So when you are going to integrate this two, then it is known as hybrid. Hybrid generally we are avoiding because the process of changing from fossil fuel to the battery or the fuels is a little bit complicated when it comes to the hybrid electric vehicle. Now, this the plug-in electric vehicle and battery electric vehicle, where we are keeping the battery and we are charging the battery. And for the battery electric vehicle, we are going to keep the battery and we are going to swap the battery after some distance. So here I am concentrating more on this part. So we can see most of the electric vehicle consists of these components. So if I am taking its common, so it is having internal combustion engine, and which is used for, which we are using for previous or this conventional transportation sector to power up the motors and all. So here we are having motor drive. And for the electric vehicle, when we are talking about the electric vehicle, power electronics is going to play a major role, because power electronics is the subject which can convert the different form of energy into the different form of energy based on the load. So if you are having battery or motor as a DC, it will convert AC to DC. If your motor is AC, it can convert AC to AC. So all the conversion process with the control techniques we can use with this power converter circuit. So here for my research work, I am going with the AC. We are going to convert DC to AC. So my voltage, input voltage will be DC and output voltage will be AC, where I'm using a three-phase induction motor in the motor side. So why? So as we have seen, which from this graph, all this graph, whatever I have represented, I've taken here, I have given the source from where, internet source from where I have taken the reference. So that is source in the downside. So we can see in this graph the growth of electric vehicle in India. So we can see, if you go back just 10 years or 12 years back, we have not seen any news about this electric vehicle, that there are rarely it will be seen in terms of a small vehicles and all. But if you see the graph here, so gradually the market size has been increased, and this last 3 years after COVID, there is a huge growth in the electrical vehicle market. Means the manufacturing company, they are changing their trend. The demand is because in India, we know that India is one of the country in the last 5 years, the growing capacity and the economics of the India is changing, and the person, they are investing the money on the electric vehicle to purchase and to make the environment to mostly they are helping the environment to grow. Now you can see in this last 3 years there is a huge demand. The market size has been increased from some trillion to billion. So you can see by 2025 that it is expected that market size will be in the $13.833 of thousands. We are talking about thousands. So we have seen a 52% of growth in this 10 years, and which is a good sign in India, that most of the people, they are changing their conventional use of transportation to the digital way of transportation. As we know that as we are growing, we are seeing the electric vehicle growth, it requires the source, and the source is nothing but the battery. And we have seen, as this transportation sector is moving towards the EV, we require a huge amount of battery, huge amount of DC battery, because we are converting DC to DC or DC to AC. Anything which is converting, that is converting from the DC source only. As we are talking about the DC source, so lithium ion battery is one of the most used battery because of its performance. If you compare with nickel metal hydride battery or lead acid battery, if you compare with the specific density, weight density and all, we can see that lithium ion battery performance for better mileage is is very in the higher side as compared to other batteries. So as the EV sector is rising, which intends directly, it's giving the boom to the lithium ion batteries, or the manufacturing companies who are manufacturing this lithium ion batteries. So what is next? So we are going to what is next? We are going to see that to make the environment green and clean, so you have to consume less and less non-renewable energy sources such as coal, then fossil fuels and all. So how to change, how this transition will happen? This transition will not happen within a day. We know that this fossil fuels is very easy to use and it will give more efficiency. If you compare to any coal-based thermal power or some solar plant-based thermal power, we can see the efficiency will matter. The coal will have more efficiency to the solar thermal power. But what? So how we are going to change? So the change will be bring by this power electronics. So where you are going, where we are going to include power electronics in our system. So by including power electronics in my system, so here we can see in the diagram, we have taken some of the renewable energy sources in form of solar, wind, hydro, ocean, geothermal. That is going to be converted using power converter, and we can give to the loads and the different loads such as electric vehicle, grid system, and other things which needs conversion. And we know that solar, wind, hydro, if we are converting, we need some switches. It needs conversion to boost the voltage. Then only we can fulfill our needs. Otherwise, it is very difficult to fulfill our needs with this renewable energy sources, because we know that the sources are there, they are unlimited. Then also to convert from one energy to another energy, there will be losses. Therefore, coming with the new topology and all, it will help the which will help this conversion process, and which will increase the efficiency of the power. And here I have seen that I have taken the 4 batteries, and I have taken from this from the reference of my paper only. So where a lead acid battery is there, nickel metal hybrid battery is there, lithium ion battery is there, and one more battery is coming in this market. Is nothing but fuel cell. So as my research, I was thinking for the fuel cell to incorporate fuel cell, but if I see the cost in India, the fuel cell cost is too high. Where if I have to go with the hardware part, I I will be unable to incorporate this fuel cell. Therefore, I am going with the trend, which is nothing but lithium ion battery. As I compared in this chart, we can see if the y-axis represents the vehicle test mass, where it talks about the weight, and the x-axis represents the range. What is the range? Which battery will give how much range? If we see this, the performance of lithium ion battery compared to this lead acid battery and nickel metal hybrid battery is far better than these two batteries. So mostly most of the places, most of the companies, most of the manufacturing companies are using lithium ion battery for the EVs instead of the lead acid battery and the nickel metal hydride battery. So what I'm why so in India still there is a challenge. There is a challenge to adopt the EV to our system. What is the first thing? So the first thing is cost. So cost will play major role in purchasing this type of stuff, because we know that whenever we are going to purchase anything, we will see what is the quality and what is the quantity. So how much far we can go with in one sort of charge. So here we will talk about mileage. So these are things will be challenged, because if you see the electric vehicle, small vehicle also, if you see two-wheelers which is coming in the form of Ola and all, they are charging 1.5, and not 1.5 for only for the two-seaters. Maximum 2% can sit. But for the same for two-wheelers, for the Honda and all, with the fossil fuel-based, diesel or petrol-based, they are having maximum capacity and the higher speed. So still the most of the younger population, they don't want that clean and green society. They want the speed and the mileage. So, and for that, for the low in the same budget, they are getting the better fossil fuel based bikes. Then limited model and the variety, yes, it is very limited. Many companies just now, they last 2-3 years, they have changed the design. So still it will take for the companies to come with a different model and the variety which will attract the population. So it's the challenge. Third is very important, lack of consumer awareness and education. Yes, more we are in the engineering field and we are in the Bangalore type of city, so we know about this EV. But if you go to the rural part of India, still most of them, they don't know about EV. What is EV? What is electric vehicle? What is the advantage of electric vehicle? Still there is a concern. So as a teacher, as a researcher, and we have to take this responsibility to go to all those type of places, so that because they are I still believe the people who comes from village or from the rural side, they will learn better than those who are in the city, because they know how to protect the environment. So I think that lack of consumer awareness and education is required to motivate the uh, motivate this EV selling. That is important. Now next is range anxiety. What is this range anxiety? Means whenever I am driving a car, if I don't know what is the battery charging, so this will always, there will be doubt in my mind whether I will reach to my destination or not. So this is another challenge. Then limited charging infrastructure. This is the most important thing what India is facing right now, that charging stations. So many person they have buy the EV vehicles, but charging is bigger problem in the garage. Outside, if you are going, you don't have that much of charging station. So this has to be modified in the longer run. Then charging time, as we know that for our mobile, if you take our mobile, so everyone is going with the port C type C charger. Why we require less time to charge the mobile phone? Because we don't want to wait. So therefore, charging time. So we have to reduce the charging time so that we can adopt this type of EV easily. Now, battery technology and the infrastructure challenges, standardization, safety challenges. Yes, this is important. Safety challenge here we can see there are some of the cases has arisen in last 1 or 2 years, where we have seen the battery suddenly, because of overheating or overcharge, it suddenly got blasted. So these are the challenges are in front of us. And the last one is depends on the government, the policy, and the regulatory challenges whenever you are changing from the conventional source of EV to the uh, new proposed EV method. So with this introduction, with this motivation, I have gone through the different papers. Mostly the papers was Springer based or IEEE transaction in many things. I've given only the few papers here. 10 papers are there. So all the papers talked about the analysis of electric vehicle with the different inverter circuits. So here I have gone with the different papers, and I have done some AC modeling signals for my jet source inverter. Now, what is the motivation? Why I went for this topic, that is called ZSI, because when I have seen the market, most of the companies they are using DC to DC converter. Means DC will be your input and DC will be your output. This output means nothing, but I am talking about the motors. So most of the vehicles which is having input as a DC and output as a DC, they are going to use DC motors, and we know that DC motors have some if you compare with this three-phase AC motor, which is having more more weight handling capacity. You can, if you use the induction three-phase induction motor, you can handle more weights. And here we can make maximum, we can go for the four-wheeler, four-seaters and all. We can design the electric vehicles. So that was my thinking, that how to go with the when I have to go with the higher weight. Because when you are changing, we have to change from not only for the two-wheelers or three-wheelers or four-wheelers, we have to think about the lorries and all, which can carry more weight. So that's why that was the first motivation. What I came in my mind, I thought to take this as a challenge and work on this. So next, when we are working with the DC to DC converter, the first challenge will be switching converter, which is prone to noise. And wide range. Wide range is tough to achieve. Still, now that is what I was talking about, the range anxiety. So we don't know when our battery will be get drained and where will the charging station. Then number of electronics devices, because we are changing from DC to DC, then you are using boost converter. So when you are adding many circuits, it's getting added up. So many it will be adding. So it will, if you add many things, what will happen? If you add many things, if you add the components, your cost will increase, as well as the frequency interference will happen between the two electronic gadget, which again is one of the concern in this area. Now this is my conventional circuits. So this is nothing but all other things are in under the literature survey. So this is VSNI and CSI model, which was developed in 1990s, and we can see the VSI is known as voltage source inverter and CSI is known as current source or inverter. In my left hand side, this is voltage source inverter, and here we are going to attach one capacitor in parallel to the input DC input. Whereas for the CSI, we have to connect one inductor in series with the input. So the CSI we are going to connect C capacitor in the parallel. In the CSI, we are going to connect inductor in the series. Those there are the different models have been analyzed. So VSI mostly used for the medium weight, medium capacity power, power application, where CSI is used for the higher application, so higher power application. What we can say. So what are the disadvantage of VSI? So what are the disadvantage of VSI and CSI? We can see that first thing is output voltage was fixed, means we can't see the range of the output voltage. It will not, if the input voltage is and 50 volt, your output will be nearby 60 volt, 60 volt, 60 volt line to line. Then we need an external circuit to boost the voltage. That was one of the disadvantage. And the third one is, which is very very important, is a shoot through state. Means when you are by chance for a few millisecond, when two of the switches are turned on from the same leg, what will happen? It will destroy the circuit. That's why shoot through state was not good for this BSNI CSI topology. And the third one is LC filter. We have to use LC filter, which causes the losses, and control is more complex.
More complex.
So next, these are the ZSI and its variant. You can see the first the first one is a normal ZSI. The first one you can see the normal ZSI, which is having two capacitor and two inductors are connected in X form, and we are having one input voltage V in and output voltage, and which is having 6 switches. And here I have taken 6 IGBT switches. This is not for the analysis; it's only for the literature survey. The second one is which is known as bidirectional Z source inverter, where I have used one where one in place of diode that switch is used. And the last one to high performance ZSI. Here diode with switch is used to perform the circuit. So these are the different currents Z source inverters that I have gone through my literature survey, and this is called embedded source, where we have used 2 voltage source. So here we have used 2 voltage source, and in the third one is something like quasi Z source inverter. So all the things I am going to do in details in my analysis part. So this is called as transformer based topology. Here there are 2 methods to achieve the output voltage. First is by changing the duty cycle, and second by changing the winding ratio. So here you can see there is 2 transformers. So by changing the windings, we can change the output voltage. So there are different topology I have gone through for the different circuits, to mostly how to boost the voltage and how to increase the efficiency, so that motor will operate efficiently. So these are the things, and this is the comparison table. So there are different comparison I have done. Bidirectional Z source inverter, what are the disadvantage, advantage, all the things have been mentioned in this slide. So first I'm trying to go to the problem statement and the circuit diagram, because time is 45 minutes I have to complete. So by going all those things, by seeing all those topologies, ZSI, VSI, QZSI, embedded ZSI, I came to the conclusion that most of the topology of ZSI which can be utilized for the drive application with high efficiency, reliability, and low cost. Most of the proposed models have complex hardware requirements and the control techniques. The topology studied have not specified about the quality of the power. So most of them, they have not done the design in the details, and the quality of power delivered by the converter to the derived EV and EHV not properly discussed. The minimum possible input DC voltage, boost factor, ripple inductor, passive components, and the cost of the conventional circuit. So here I will take a little bit of time. So as we know that voltage source inverter, in the voltage source inverter, there are two modes. One is known as null mode and one is known as active mode. In null mode, either three of the switches, so you can see three of the switches, either switch 1, switch 3, and switch 5 will be on, or switch 3, switch 6, and switch 2 will be off. So null condition means 1 1 1 or 0 0 0. So in this condition, what will happen? Your voltage, because your circuit is not a closed circuit, your voltage and the current across this output will be 0. And for the active state, we'll turn on the two switch from either from the first half of the leg and one switch from the bottom half of the leg, or two from the bottom and one from the upper half of the legs. So if you do this, it will work as a normal inverter, which will convert the DC voltage into AC voltage. But the problem will come when there is a dead time, because as we know that when you're transition from null mode to active mode, what will happen? There will be a dead time. And dead time means what? For few milliseconds, both the switch from the same leg will be turned on. And what will happen if this two switch will be turned on? This circuit will be short circuit. And if you use this 6 switches with VSI arrangement, what will happen? It will destroy the VSI or CSI model. So what we are going to do? So we are that in 2001, P. Wang Cheng came with a model which is known as ZSI model. Here, the capacitor, this inductor 1 and capacitor is connected to the parallel. Inductor 2 and capacitor 2 is connected to the parallel. What will happen in first stage, when normally it will work in the first as active state, where two switch from the upper leg and one from the bottom, or just reverse, two from the lower and one from the upper will conduct. It will work as a normal inverter. But when we have to create the shoot through, what I will do, I will turn on this switch together. Once you will turn on this switch together, this is this state I'm talking about. When I'm turning on this two switch together, what will happen? The capacitor C1 and this capacitor C2 will come in series. Once it will come in series, then voltage VC1 and VC2 will be get added. So this two voltage will get added. What will happen if this two voltage will get added? Then the capacitor voltage across this two capacitor will be greater than, so this capacitor voltage will be greater than the input voltage. Once this happens, once the capacitor voltage is greater than the input voltage, this diode will be reverse bias. It will not allow current to flow. So current only will flow here. So what will happen? Here we will get capacitor voltage VC1 plus VC2. So you will get total capacitor voltage as 2VC. So means in this shoot through state, the voltage, the capacitor voltage got twice. And after the next mode, which is nothing but non-shoot through mode, your ZSI and inverter will work as the normal inverter, but with addition with a 2 VC. So that will be V in plus 2 VC, means your voltage has been boosted. So if you have some 100 volt, that voltage have been boosted to somewhere 120 or 130 AC without using any boost converter. Without using any boost converter, this circuit is using to control and boost the input voltage without using any boost converter. So this ZSI model is used to boost the voltage as well as buck the voltage. And that's why if you compare with the DC to DC converters and all, this will give you the extra advantage as compared to the normal inverters and the DC-DC converters. Now I have done the circuit analysis. So now this is the total time. Total time is nothing but the shoot through time plus the active time. So this we have to give, and we can see from the diagram VDC equal to V in plus VC minus VL. So this is nothing but this is for the shoot through stage where we are this is the VDC is nothing but my DC link voltage. What is DC link voltage? The DC link voltage is nothing but the boosted voltage, which is written as V in plus 2 VC. So DC link voltage is nothing but a boosted voltage which is represented here. So this is my boosted voltage. This is in the form of VDC. After that, this voltage is converted in using the 6 switches pattern. Now, the V in the input DC voltage, VDC is DC link voltage, VL is inductor voltage, VC is the capacitor voltage. So these are the derivation, these are the equations I have derived from the earlier diagram from the shoot through and non shoot through state. And here the time interval I have taken where the shoot through states will create from 0 to time t, and by using this capacitor VEC by V in, I have designed the duty cycle and the modulation index, because this B represent the boost factor, and there is one more thing called M. M into B is nothing but the voltage gain. Voltage is nothing but the input by voltage gain is nothing by the input by output. Input by the output. Output is your here our output is a BAC. Sorry. Sorry, here I wrote wrong. So what is voltage gain? Output by input. So VAC by VDC. So VDC here will be VDC by 2. So here my voltage gain. So voltage gain depends on the boost factor as well as the modulation index. So by varying the duty cycle, the voltage gain can be adjusted as per the switching pattern. Now, the important thing is boosting, because ZSI, whenever I am talking about ZSI means when we are going to boost the voltage, and as well as we have to convert. That's why ZSI technology is more useful. Here ZSI will boost the voltage as well as it will convert the voltage from DC to AC. So for that, there are different boosting schemes are there. First one is carrier based PWM traditional voltage source. Next is simple boost controlling technique. The third one is maximum boost controlling technique. Fourth one is maximum constant boost controlling technique, and the fourth one is maximum constant third harmonic injection controlling technique. So each of the technique used to boost the DC voltage. So one by one we will go through. So first is carrier-based PWM technique, and as everyone knows this is a commonly used where we are going to compare the sinusoidal wave, which is nothing but the reference wave with the triangular wave. So whenever we are doing this is called normal PWM method. So whenever the triangular wave is known as carrier wave and the sinusoidal wave. So here we can see we are taking 3. So VA, VB, and VC is nothing but 3 sinusoidal reference wave, and this is the triangular wave. This triangular wave is nothing but carrier wave. Now, when you compare this sine wave, reference wave with the triangular wave, whenever the triangular wave is greater than the sine wave, it will produce the positive. Whenever greater than, it will produce the positive gate pulse. It will produce the positive gate pulse. Whenever the triangular wave is lesser than the sinusoidal, it will produce the negative gate pulses for all the switches. So this was the earlier concept all of you know. So 111 is nothing but when all the 3 switches are on or off. So when you are transition happening from 111 to 100, we can see here 111 means all three switches from the upper half is on. Means lower half no one is on. So the switch is having 0 voltage. But here we can see 1 from the upper leg, 2 from outer. So you are getting some, we are getting some voltage, output voltage you will get. But here the dead time, this is called dead time. So dead time means when both the switches are on and a high current will start flowing from uh, load to source, and that will be the dangerous. And here only the problems comes here in this type of conventional PWM inverter, where we can't generate the shoot through, we can't boost the voltage, there only the problems comes. So to boost the voltage, we have to choose. There are different types of PWM techniques. One is known as simple boost control technique. What we are going to do here, we are going to take similar to that. We will take the three reference wave, VA, VB, and VC. Three reference. Then we will take a triangular wave. And with this, what we will do, we will take two more constant wave at the upper and the lower side of the waveform. So we will take three waves actually. One will be the sinusoidal reference wave, VA, VB, VC. Then one will be triangular wave, and one will be constant wave, which will be placed in the upper half and the lower half of the envelope. Now we are going to do, we are going to first we will do compare the sine wave with the triangular wave. That is first. That will generate the pulse, and that will generate one PWM pulse to the circuits. Next, what we are going to do? Next, the upper constant wave and the lower constant wave is going to compare with the triangular wave. Is going to compare with the triangular wave. So what will happen there? There, it will create shoot through pulses. It will, you can see here. After 111, we are not going directly to 100. We are going to this dark line we can see here. That is nothing but the dead time or the shoot through. And in this, this shoot through will be for very, very small period of time, for millisecond, microsecond we can tell. And in this process, we are going to boost the voltage to a desired level. So you can see in this graph, which is there in the right side, the voltage gain versus modulation index. For simple boost control technique, the modulation index can be varied till 0.5, and we can achieve a voltage gain of 0.55. But there was some limitation, because when you go with the simple boost technique, there was voltage stress, means the stress across the voltage, the capacitor and the switches are more. To reduce those voltage stress, we are going with the maximum maximum boost constant technique, where we are going, what we are going to do here, we will not take any. Here we are going to take the three waves, and we are going to maximum means maximum of the wave, maximum of the reference wave will be matched with the triangular wave, and minimum of the maximum of the negative will be matched, and where it will cut, it will produce the shoot through. So this is the difference, and we can see that if you compare the first circuit and the second circuit, the modulation index is achieved. We can vary this modulation index by 0.6, and we can get the voltage gain, and we can the range of voltage gain is from 0 to 0.8. So this is the difference, which, and it will reduce the stress across this across the switches. So these are the two techniques. So we can see that this one I have done from the MATLAB. We can get this, and these are the techniques, and this is the important one, the third harmonic injection. So in the reference wave, the third harmonic is injected, and again the same technique we are going to apply. This is VA, this is VB, and VC. This is the third one is the VC. These three are known as reference wave, which is compared with the triangular wave. And whenever the triangular wave is whenever the triangular wave is greater than the reference wave, it will produce normal PWM pulse for the 6 switches. But whenever this constant line, you can see this two constant line, one is in the upper half of the envelope, one is in the lower half of the envelope. Whenever the triangular wave is greater than this constant line of the upper half, it will produce positive shoot-through pulses and negative shoot-through pulses. At last, both of the pulses are added and given to the circuit. So this is the comparison table I have made. So we can see if you compare all these 4 different techniques, that is nothing but simple boost control technique, maximum boost control technique, maximum constant boost control technique, maximum constant boost control technique with third harmonic injection. Then we can see that the last one, the final one, that is nothing but constant boost, it is having the less voltage stress, but having the minimum gain. Voltage gain you can't change. That will be there in the less range. So if you compare that, you can see the dotted line, maximum constant boost control technique. If you compare all this the third one, it will have the lesser TSD, means analysis, TSD analysis. At last, we are doing the TSD analysis. So this technique will give you the lesser TSD, harmonic distortion, but at the higher switching rate, means the switching frequency will be more, which will cause the switching stress as well as switching losses in the switch. So as I compare all the 4 techniques, this technique is having little bit more TSD, but the voltage stress and the switching loss is less when compared to all other 3. So these are the governing parameters I have taken for this too. So we can see the shoot-through duty ratio. We can see 1 minus m for this simple boost. For maximum boost, you can see 2 pi minus 3 root 3 pi by 2 m by 2 pi. So we can see that the simple boost technique causes maximum voltage stress across the switches. And if you compare all the equations, if you see all the governing equations, from there I can achieve this graph, and which tells me that maximum constant boost control technique plays a vital role and to achieve less harmonics distortion with less voltage stress as well as switching stress. So this was my inverter part. My second section is for the motor selection. So how to, because I told my area is EV. So EV means motor means EV means tire means motor. I have to select motor. So here, as my converter circuit is nothing but DC to AC, so I have to select a AC motor, and here I am selecting a 3-phase AC motor. For that, what I have done, I'm going with a prototype where my 4-wheeler car is of 111 kg. So these are prototypes. This prototype means what I am going to install in my lab setup. I'm not going to install for full car, so I'm going with a prototype with a mass of 80 kg of a driver, a single person driver I'm taking, and the initial velocity and maximum velocity which can be obtained is nothing but 40 km per hour. 40 km per hour. So these are the parameters I have taken to set to find out the capacity of my motor in the form of kilowatt hour and the torque. So here I am going to take my vehicle, and I am running my vehicle in the plain road. So I am taking this angle, this sine theta. I am not going up, not going down. So I am going to take that sine theta as 0. Why I am taking this? Because if I will take these values, then other parameters I have to add. So and this is used to determine the vehicle motor size and the motor weight. So while doing all those things, we can see that the speed that this is the motor speed, which is nothing but we can achieve by, up to 2715.96 RPM. And here is the torque. How much torque is required? 3.63 Newton meter. And power. So this is the important thing. Power of one motor I am getting with this design, I am getting 1.032 kilowatt. So here in my circuit, I am going to use 4 motors for the 4 tires. So it is coming about 4.128 kilowatt. And here I have done the motor comparison. As I told you that if there are different companies. Some companies are working on DC motors, some as a load. Some of the companies like Toyota and all, they are using DC motors. Some of the companies like Tesla, they are using three-phase induction motors. So different companies, they are going with a different motors. So I have done one survey analysis where I can see this M represents medium, L where L represents large. So all the different parameters such as power density, reliability, efficiency, cost, size, controllability, speed range, maximum torque ripple, acoustic noise, and the technology maturity have been paired. And this mostly this table I have done to select my motor, that is nothing but a three-phase induction motor. And next is battery management. So once I selected my load, I have to select a source which will give the power to my three-phase induction motor as a load. So here we can see when I am selecting as a source, I am going to select lithium ion as a battery. When I am taking any battery, there are few challenges which is represented by the battery management system. So what are the things? So discharge and charge control. How fastly I'm going to charge and discharge my battery. Fault diagnosis and assignment. So whenever any fault happens, when I am traveling and something happens to my battery, how we are going to diagnose those? Then how we are going to give the protection to the battery? Then in the summer season, current and voltage. If you are having more current and voltage, if in the summer season you have seen that battery will get heated up. So how to see the current and voltage monitoring? Then cell balancing is one of the challenges in the battery. Next will be thermal management. As we have seen that most of the cases is coming while running, while standing, the two-wheelers or three-wheelers vehicle are catching fire. Why it's happening? So these are the challenges are there in the battery management system. And the last one is the state of charge and state of health of this and a state of temperature of the battery. So all those things we have to take uh, take uh, take take in the points whenever we are selecting any battery. So this is a battery comparison I have done, where I have taken the lead acid battery, nickel cadmium battery, nickel metal battery, and lithium ion battery. And I have taken the parameters such as specific energy density, internal resistance, cycle life, fast charge time, overcharge tolerance, self-discharge, self voltage, and all those things. So safety maintenance, all those things I have taken. I have taken the reference from one of the paper. So we can see if we compare all the voltage, all the batteries, we can see the lithium ion battery. We can see the parameters. All the parameters will be in the higher numbers. Means this battery can or then it can take only 2 to 4 hours to charge. Others are taking 8 to 16 hours. Someone is taking 1 hour, but their other things are very much higher. So if you take all those things, lithium ion battery performance for EV for the same amount of cost is much better. So these are the lithium ion battery advantage: charging and discharging of the batteries, improved development of advanced BMS for EV, high performance for maximum load and distance, because that is the only the challenge. Because what is the maximum distance we are covering with how many persons, how many distance will go? So this will be the challenge. Withstand temperature. So I told you in the summer season, sometimes a battery will worse because of the high temperature. So how to withstand that? So if you take all those things in the picture, so that you can select your battery very much efficiently. So now I'm going to my proposed circuit. So in my proposed circuit, I have used two battery. So that's why my circuit name is dual port or two port. Why I'm doing this? To achieve the maximum range and to get the maximum power to rotate my motor to power up my motor. I told my one motor is taking nearly 1 kilowatt of power. So that's why I have to boost the power, so that I have to go with the double battery to control over the induction motor and to control over the distance. Next, control complexity should be reduced. a lower component rating by using the joint earthing, and the input current continuous. As I have told you, jet source inverter was having some disadvantage. What are the disadvantages of jet source inverter? The first thing was discontinuous current. Means current was not flowing discontinuous because of the diode. So for some amount of time, diode will be reverse biased and will not allow current to flow from source to load. Therefore, that was having discontinuous current. That was the challenge. Correct. We can't use ZSI for our EVs. That's why we have to come with some other topology where you will have the current flow which is regular. So this is my proposed circuit diagram which I have used for my research work, where we can see I have used two batteries. So that's why I have given the name dual input source, and this is nothing but this is the arrangement of quasi jet source inverter, where we can see the current cannot be discontinuous, because if this diode, this switch 16 is nothing but a diode. If this dot reverse by, then also my current will flow to the load without interrupting the current. That's why in my proposed circuit, the current will be continuous and the complexity of the circuit is reduced, because I am using the two or dual source of input. And here I am using two loads. These loads are connected to two motors. So I am using 4 motors and I'm using 9 switches to operate this 4 motors. And these all this S10, S11, S12, S13, S14, S15 represents the diode. So these are the two modes of operation. So in the first mode of operation is known as non-shoot through mode, where the switch will work as normal switch. Two switch from the same leg, and one from the bottom leg will operate. And from the second, where I'm going to turn on both the switches, and we are going to create the shoot through state. So these are the design parameters from the shoot through state circuit non-shoot through mode I have designed, and I've given this governing equations. This is the steady state analysis of my AC circuit. So here I have 4 parameters. So here 4 parameters is designed, and this has been incorporated to the small. This is important. This is called problem formulation. I am going to use. So here I have used the neural network to achieve to generate the pulses in continuous way. So here you can see the switch is nothing but diode, and here this other calculate network output, learning rate, and other switches online mode. Why I'm using this? Because it will give me the frequent generating pulses to the switch, which will help to achieve the maximum output voltage during the output time. This is my simulation setup, which I have done in the same thing I have done in my MATLAB simulation. And here I have used 3-phase induction motor, and with this 6 switch, and this one is nothing but switching sequence. I have used that maximum constant boost parameter techniques. These are my parameters which I've used to get the output, and these are my winding turns L1 and L2. This is the source 100 voltage. The winding turns is for 67 and 47. Coefficient coupling of 0.99. Mutual inductance of 0.424. Switching frequency of 10 kilohertz. Reference frequency I told 50 hertz, and the modulation index of 0.85. And here I have taken for the RL load of the value of 25 ohm per page. And this is the switching pattern. And this is I have used maximum boost constant technique to generate this switching sequence, which I have discussed earlier. These are the my results. So you can see my input voltage was 100 volt, and which is boosted which is boosted to 350, but it settled down around 250. So my settling period is for after this 5 cycles only my waveforms are getting settled. So we can see we can achieve up to 230 to 240 or 280. We are reaching to nearby 280 volt in the DC. So the DC voltage has been boosted from 100 volt to 280 volt, and this DC voltage is converted into line-to-line voltage, and these are the three line-to-line voltage VAB, VVC, VCA, and we can see that this is settled down after 4 to 5 seconds. It is settled down somewhere here, and our voltage, so that 100 volt is boosted to nearby 200 line-to-line. This is the electromagnetic torque produced in the motor side. So we can see the transition time is from 0.2 to 0.5 second, and the torque developed. So initially we have achieved the torque of nearby more than 4.4 Newton per meter, but after 3 cycles of transition, we can see that torque is getting settled at around 3.8 and all. So as I told you that my torque, my theoretical torque and my practical torque is nearby matching, and it will be suitable by using this two-port network. So these are the main current, auxiliary current of the induction motor. So this is important. See, here we have used trans jet source, and here I have used two-port source. We can see the voltage stress with using trans jet source inverter was around nearby 158. But if you use the quasi jet source inverter, the capacitor voltage means the voltage stress across the capacitor is reduced suddenly by 100 volt. Now we are getting around 58. So here we can use one more capacitor in form of battery to and we can use this as an extra battery source to achieve the higher range of for the EV. So these are the load current and line voltage of this proposed circuit and the conventional circuits. This is a step response of my proposed work. We can see that the first 50 to 100 cycle my system was unstable, but after 150 of cycle that system was started. It means my system is getting stable after 0.003 second, which is quite low. And this is my TSD, and for my conventional proposed circuit, my TSD level is 5.09%, which is very good for the motor and to achieve high speed for a better range. This is my hardware setup, what I have done in my lab. Thanks to the School of EEE and REVA City to give me the setup. And here I have used the motor and this setup to achieve my and to match my simulated circuit with the hardware circuit. So this is my hardware result. So we can see my hardware this DC voltage. What I have achieved is matching with my simulation voltage, and these are the voltage and current waveform captured through the hardware for the induction motor. So what is the conclusion? We can see from the conclusion, Z source inverter is having 6 number of switches where we are getting for the linear load condition, we are getting 5.52% of TSD. For trans Z source inverter, I am achieving 5.541. For quasi Z source, we are using 8 switches and we are getting 6.21, and 2-port quasi Z source inverter, which is having 9 switch, but my harmonics distortion is very less as compared to other 3 topology with same linear condition. For non-linear condition, again, if we compare with all other topology, the 2-port quasi Z source inverter having very less TSD harmonic distortion, and which will be useful to run a motor. So I came to the conclusion. So what is the conclusion? A step input response to the current controller for the system is calculated. And we are getting 5.89%. We are seeing the TSD, and which is very important, because to make the TSD less than 10, which help the motor to run in smooth way and to get the better output. And I told you that my system is getting 34.67 microseconds while to provide the current. And the result and the experiment analysis present that during the acceleration of the trans Z source is providing the required amount of current, and my system is settling down at 0.3 seconds. That is one of the important things. And this method can be realized in future for achieving the independent motor control action in 4-motor drive system. So, so overall, this is the conclusion. I have compared the 4 different topology with a modulation index of 0.085 and an index and a resistive load of 25 ohm. And I have shown in the tabular column that my 2-port quasi-jet source inverter, I am getting the harmonics less than 5% as compared to all other topology. So these are the references. I have more than this reference, but I've used this reference in my slides. And thank you all for listening patiently. And thank you all. Any question, please ask.
Okay, thank you so much, Mr. Professor Manish Bharat. To participant, are there any question kepada teman-teman sekalian? Apakah ada pertanyaan?
Asked me that the efficiency of jet source inverter is lower than ZSI topology. How to increase the efficiency of jet source inverter? Yes, I told how to increase. Then you have to select. There are 4 different topology I told. So that is nothing but simple boost. Simple boost. I told about the simple boost technique, then maximum boost technique, maximum boost constant technique, and third harmonic injection. So you have to select either one of the switches and one of the PWM techniques, and you have to apply this technique on the ZSI circuit. You have to see which switches you are going to select, but there are different types of switch. IGBT is there, MOSFET is there. MOSFET is good for the high frequency, where IGBT is good for the medium frequency. So if you see the PWM techniques and you relate with your devices, semiconductor devices, you can achieve the efficiency for the jet source inverter.
Okay, let's move to this conversation with the topic computer vision to Mr. Professor Dr. Vorapoj Patanavijit. The floor is yours.
Okay, share the screen. Okay. Everyone can can see my screen.
Yes.
Okay. It's about my research work. It's about image processing and the computer vision. Okay. This a comprehensive achievements investigation of the iterative mean filter for Outlier, Extinguish, Aspiration on the Ubiquitous fixed values Impulsive noise. This work is work with by my sister and my corporate. Okay. My name is Associate Professor Dr. Vorapoj Patanavijit, okay, from the Thailand. Okay, and another one is Assistant Professor Dr. Kornkamon, okay, the Suvanan from the same university. Okay, the first one is about the abstraction. Under the Commonwealth of the Outlier Extinguish inspection exclusively on the impulsive outlier, the Outlier Extinguish algorithm is a substantial step which is earlier performed prior further computer vision step. Thereupon, the iterative mean filter is inaugurated for the fixed value impulsive noise and grows into the one of the superior achievements Outlier Extinguish algorithms. These academic articles focus to investigate the cooperative achievement of the Outlier Extinguish algorithm established on the IMF is inaugurated from the means filters for carry out the poor achievements of the Outlier Extinguish algorithm, such as the SMS, MF, and the AMF for the FVIN at the omnipresent scattering of the Outlier consistencies from the 9% to 5% to 90%. The analytical experiments comprehensively explore on the multiple figures in the apparent F-16s, the gold, the RENA, and the paper that are inspected in order to analyze the correlative achievement of an Outlier Extinguish algorithm established on the IMF. In contrast with the affordable says, Outlier Extinguish algorithms, SMS, MF, and AMF, the Outlier Extinguish algorithm based on the IMF have the superior achievement from the experimental result. This lecture is separated into the 5 sections. The first one is the introduction and present about the reviews, literatures. The second one is about the concept of the modern outlier extinguish algorithms. The third one is the concept of the novel iterative mean filters. And the next is the experimental result. And the last one is the conclusion. The first one is the introduction. So why the denoising or the way to reduce the noise is very important. Under the Commonwealth of the digital image processing and the computer vision, there are bountiful ongoing utilization on the digital figures or the digital image in the last 20 years. Thereupon, one of the substantial steps for ongoing computer vision utilization, for instance, the several frame super resolution or the single frame super resolution, the face categorization or the recognition, and so on, is the outlier extinguish algorithm because the advanced or the progressed digital image processing algorithm are naturally the deficiencies to the outlier. Under the circumstance, the outlier extinguish algorithm is one of the substantial steps for ongoing the computer vision utilization upon. Thereupon, there are bountiful inventions for desiring proficient outlier extinguish algorithm, which early in is made from the outlier detection algorithm and the outlier extinguish algorithm. The first one is in the 1975, the standard medium filter or the SMS was earlier inaugurated for extinguish FVIN, and the next has been grown into the one of the superior achievement of the outlier extinguish algorithm. In order to extinguish FVIN on the color filter, the VMF or the vectors median filters, which is inaugurated from the ordinary SMS, was proposed to be one of the classics outlier distinguish algorithm for colors image. After the AMF or the adaptive median filters, which was extended from the SMS with an expanding progressive window, was inaugurated to be an outlier extinguish algorithm for the FVINs in the 1994, and the next has been prospects to be one of the classics outlier extinguish algorithm with the superior achievement. In the 2017, the outlier extinguish algorithm established on the boards a value limitation cast extinguish and the swarm argumentation was inaccurate for engaging the colors image. For which, self-moving electronics abatements examination algorithm established on the SVM's descriptions for the MRI's brain figures was inaugurated in the 2017. Later, the outlier extinguish algorithm based on the outlier's regularity estimations by restricted area statistics was inaugurated for the digital image in the 2016 and in the 2018. The outlier's extinguish algorithm established on the phosphorus filtering techniques was subsequently inaugurated for the colors figures. Succeedingly, the alternative outlier extinguish algorithms based on the combination of the window filter and the Gaussian filters was analyzed. Its achievement by fluctuating the kernel specification is in the 2019, and after the outlier extinguish algorithms established on the filtering techniques was analyzed. Its achievement in the medical figures or the medical image in the 2019. The bountiful outlier extinguish algorithms established on the particular techniques are inspected and correlated analyzed on the many outlier extinguished perspectives by the Bharat in the 2019. Okay, and since the 2020, then alternatives outlier extinguish algorithm based on the compartmental wavelength techniques, with this expanding from the high wavelength as the compartments ordered by a low pass filter, generalizations with the compartment delay operation was inaccurate. For employing on the underwater acoustics outlier, the outlier extinguish algorithms established on the discrete wavelength transform with the outlier consistencies assessment was inaccurate in the 2020. This is about some part of the literature review read to the concept of the modern outlier extinguish algorithm. The beautiful ongoing outlier extinguish algorithms, which was generally invented for the outlier detection and the outlier extinguish, has been inaccurate as the successive. In the 2017, the outlier extinguish algorithms established on and in cross statistics techniques was inaccurate for extinguishing and impulsive noise. For then scattering consistencies of the FVIN and alternative outlier extinguish algorithms, so-called adaptive decisions based inverse distance weight interpolation or DWI algorithms, which was inaccurate by Ubiquitous Baspu in the 2020, was analyzed its achievement upon the around omnipresent scattering on the FVIN in the 2019. And in the same year, the beautiful ongoing the outlier extinguish algorithm established on the road techniques ROAD and RORD are correlatively analyzed for perceiving the impulsive noise, our impulsive outlier. As following the outlier extinguish algorithm established on the triple threshold statistical detection technique was inaccurate for FVIN in 2018. Afterwards, the outlier algorithm established on the IMF, which was expanding from the traditional SMF techniques earlier, is expand from the FVIN at a high density in the 2019, and this algorithm can produce the superior achievement. As a result, this academic article addressed to inspect the outlier extinguished approach established on the IMF, which is employed on the range of the noise, okay, on the beautiful image, which are unified on the F16, arena, and the paper. The concept of the novel iterative mean filters. The virtual expectation of the IMF is inaccurate from the mean filter because the mean filter have the superior achievement for the low scatterings of the outlier consistencies or at the low noise rate. Okay. Furthermore, it is a simple complication. Whereas the mean MF occupy a non-expanding progress window in contrast with the expanding progress window filters such as the adaptive median filters or the modified decisions-based algorithms median filter or the noise adaptive foxes switching median filters. To necessarily prospect IMF earlier, the IMF occupied the dominance of the means filters and a non-expanding progress window at only 3×3. In due course, IMF reinforces the dominance with the non-expanding progress window in contrast with expanding the progress window filter. In the earlier step, the enumerate figure information is cataloged as the identified outlier information and the hypothesis that the figure information only 0 or the mean or the max, okay, 0 or 255 should be about the noises, okay, pixels, and the enumerate figures information are cataloged as the non-outlier information. In the later step, only in the in the noises or the identified outlier information are exploited by arranging and non-expanding progress window to be by 3 by 3, as shown you in this flowchart. Okay. In the window 3 by 3, there are any enumerate figures information that is cataloged as an identified non-outlier information. Thereby, the outlier extinguish output is the statistical mean of every non-outlier information in the non-expanding progress window. If every pixel or every figure information in a non-expanding progress window are outlier, then the enumerate figure information is not revised or the process don't do anything. In the final step, the enumerator step will progress to the array step until the enumerate figure information after enumerations are merely indistinguishable to the enumerated figure information before enumeration. The complementary computational blueprint of the iterative mean filter is operated in this figure. The next one is the experimental result. We will show so many experimental results. In the branch of the experiment, the productivity software is the MATLAB, which is built on the experimental of the body foods desktop, with the applicant's technique is about the i7s and the 6th and the 16 GB RAM. The particular desktop are examined on the body food figures, which are composed of the F16 skull, rhina, and the pepper, and all experimental figures are manufactured with the FVIN at the omnipresent scattering of the outlier consistency from 5% to 90%, and for outlier extinguished aspiration, omnipresent scattering of the outlier consistency, experimental fallout of the achievement of the IMF on the body food figures from 4 images are examined in the table 1, 2, 3, and 4 correspondingly. In order to decorate the outlier extinguished achievement, the IMF was exemplified in contrast with the body food outlier extinguish algorithms such as SMF, MF, and adaptive median filters. The first one is the F16 as the result of the F16 figure that show you in the table 1. The widespread outlier extinguished achievement of the IMF have a preferable signal to noise ratio in the decibel is a greater contrast with the mean filter, median filter, and the adaptive median filter is about, okay, 18 dB, 14 dB, and about X dB correspondingly. And we will show you only some part. This is if the noise is about 70%, okay, the real figures that we can construct show you in here from the figure quality perspective. The experimental story explore the section experimental result of the F16 for 70% in here. The first one is the original image, okay, the A2 is about the noises, okay. The top one is the noisy, and the bottom one is about the contrast between the noise and the original one. It means the more black is good to recover. It means no difference between the restoration image and the original one. Okay, from here, the mean filter is about the noisy image is about the quality of them is PSNI is about 7 dB, and for the mean filter is only 10 dB. The median filter is 10.2, and adaptive median filter is 17 dB, and for the IMF, okay, is about 20x dB. The next one is for the F16 at about 80%. Okay, the the noisy image is about 6 dB. Is the mean filter after recovering is about 8 dB. The median filter is about 10 dB, and adaptive median filter is about 16 dB, and the IMF is about 26 dB. The quality of them, you see that is can clean almost all, even though the edge of the image may be destroyed a little bit, but you see that in the noisy image we cannot see anything in the pictures, but after we restore we can see it's a print, even though it's not sharp, it's not the quality of them is not good as the original image. The last one, if the noise is up to 90 dB, yeah, is 90%, sorry. The noisy image is okay, the PSNI is only reduced to be 6 dB. Okay, the noisy image we cannot see anything in here. Okay, the mean filter is cannot reconstruct them. Okay, the PSNI is about 7 dB. Okay, the median filter is about 9 dB, but the object we cannot see anything yet. Okay, for the AMF adaptive median filter we can see them, but a lot of the noise. Okay, and for the IMFs, okay, it can improve the quality in both the subjective and the objective. The PSNI is increased up to 24 dB. The next one is about the curves as the result of the curves figure in the table 2. Okay, the widespread outlier extinguish achievement of the IMF have preferable signal to noise ratio in the decibel is greater than mean filter, median filter, and the adaptive mean filters is about 22 dB, 16 dB, and 9 dB respectively. And the next one is for the RENAS figures in the table 3. The widespread outlier extinguish achievement of the IMF have the preferable signal to noise ratio in the decibel is greater than contrast with the mean filters, median filter, and the adaptive median filters capable of nearly 19 dB, 14 dB, and the 9 dB respectively. In here, we will show that, okay, in the first case for the airplane, we will show only in the high density noise. Now we show you in the real image when we reconstruct them in a very low density noise is about 5%. Even though at the noise at the low rate, okay, this technique have the outstanding performance. From the figure quality perspective, the experimental stories explore this section. Experimental result in the RENA is about 5% in here. The originals, okay, is at the in the A1. A2 is about the noises, is that a lot of the noise is about 5%, but we can steal the image. Okay. For the mean filter cannot restore them well. It can restore them a little bit one. The PSNR of the noisy is about the 19 dB, and the PSNR of the mean filter can improve about the 22 dB. The median filter seem to be a little bit better, can improve the PSNR up to 31 dB, and the adaptive median filter can improve up to 36 dB. But for the iterative median filters can clean almost all. Therefore, the PSNR is improved up to 44 dB. at about noisy at about 10%. At about 10%, okay, it's a lot of the noise, okay, than the previous case, okay. The PSNR of the noisy image is about 16 dB, and the mean filters, it can improve the quality of the image, can make the PSNR up to 19 dB, and the mean the medium filter is about 30 dB. Adaptive medium filter AMF is about 35 dB, and for IMF can improve the image up to 40 dB. Show you in here. Next one, if the noisy increasing, yeah, the noise increasing to be 15 density, okay, 15%. The noises image have the PSNR about 14 dB, and the mean filter can improve them, make them to be PSNR 17 dB. The median filters is can clean the noise wells and can improve up to 29 dB. AMF can improve that and increase to be 33 dB, but the IMF is the best one. It can improve the noise up to 30x dB. And for the next one is for if we increase, okay, the noise up to 20 dB. Oh, sorry. Sorry. Oh, okay, 3 cases. And for the next one is for the papers figures, okay, the last figure. In the table 4, the widespread outlier extinguish achievement of the IMF have the preferable signal to noise ratio in greater contrast with the mean filters, standard median filter, and the AMF, capable of nearly about 19 dB, 14 dB, and the X dB correspondingly. For the last one, for the conclusion, this academic article focuses on the prospect of the correlative achievement of the outlier extinguish algorithms established on the IMF, which is inaugurated from the means filter for carrying out the poor achievement of the hypothesis outlier extinguish algorithm for FVIN at the omnipresent scattering of the outlier consistency from 5% to 90%, and for analyzing the correlative achievement of the outlier extinguish algorithm established of the IMF. The analytical experiment explored the bodyful figures that are unified from the F16 curve, RENA, and the paper. From the total experimental result, the achievement of the outlier extinguish from the IMF have preferable signal to noise ratio in the decibel in the outstanding greater than the SMF, MF, and the AMF. That is all. And the one last thing, this technique can apply on all image because this technique is not the training. It's don't use any training or the data sets. Okay, we can apply them very easy. Okay, the modern CPU, modern processor today can compile them, even though it's not perfectly real time, but I think it can very fast in the few seconds. Okay, that is all for my presentation. Any question?
Okay, thank you so much, Mr. Professor Dr. Vorapoj Patanavijit.
Yeah.
To participants, are there any question?
I understand that if the student maybe have not maybe not maybe afraid to ask, okay, maybe send the email to ask me after that, okay. Okay. Let's see. Some question.
In the meeting chat, there is questions from.
Yeah. Okay. I will share the screen with this question. Is okay. Some is asked that can video or audio files be processed using the iterative mean filters algorithm or not? Yes, the video can do them, okay, but frame by frame, okay. But for the audio is you must make sure that the noise in the audio is impulsive, okay. If it is impulsive, yes, you can use them, okay. The next one is the state of art of the computer's vision employed by use the ML and the DL, since the Outlier Extinguish algorithm is aimed to improve the image quality by use, okay. How common FVAN persists in? Is the image usually is contaminated by several types of the noise, okay. Some is a Gaussian noise, some is the salt and the pepper or the FVAN noise, some is the random impulsive noise. After you know that, okay, you have the area of the research or area of interest, okay, which noise you would like to clean, with noise you would like to compare to separate them, okay. If it is a FVAN or the noise is the noise is if you ask me where is the noise, what about the cause of the noise? The noise is came from the several environments. Is maybe from the electronics, from the semiconductor technology, from the transmission, or so on, depend on. If the noise, I can tell you that if the noise is fixed value or the impulsive noise, yes, this technique can clean them. And the advantage of this is you can clean or you can separate them without training. It means you can use any image to clean, to be clean, sorry. Okay.
Okay, I think there are no more questions. To Mr. Professor Manish Bharat and Mr. Professor Dr. Vorapoj Patanavijit, thank you for sharing with us.
I would like to say
And thank you for the participant for taking their time. I think that's all. Saya kembalikan lagi ke Pak Toleh. Pak Toleh.
Okay, thank you very much for everyone for attending this event. We apology for any convenience caused in this event because this event is firstly, I hope this event will be continue in the future. For second distinguished lecture series will be organized the day up to tomorrow. Okay, thank you very much for Prof. Vorapoj and also Prof. Manish and all participants. Thank you very much. Cukup mungkin Julia bisa ditutup acaranya.
thank you everyone.
Baik.
Yeah, for your okay. Other information. For your information, two paper presented in this event will be published in our journal Bulletin of Electrical Engineering, and for 4 point will be shared in our website. Okay, thank you. Silakan ditutup, Julia.
Baiklah, kita akhiri teman-teman dan rekan-rekan sekalian dengan mengucapkan alhamdulillah bersama-sama.
Alhamdulillah.
Alhamdulillah.
Thank you.
Alhamdulillahirrahmanirrahim.
Assalamualaikum warahmatullahi wabarakatuh.
Okay.
Waalaikumsalam.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
Thank you very much, sir.
Okay, thank you.